We Since we just started the recording, I'll redo the introduction that I kind of gave to Chris before he was able to jump on here. Chris is one of the bright spots out there. Us old guys in the coal business are really happy when we see young guys show up to inject a little bit of sanity into the discussion around climate and energy and those kind of things. Chris is a meteorologist. He's currently also doing some work with our friends over at CFACT, and kindly offered. He's got a very busy schedule, but he kindly offered to take some time with us today to make a presentation. We'll have a little bit of discussion afterward. So I've got the chat box open. If you've got questions for Chris, feel free to type them into the chat box or wait till the end of the slides he's prepared, and we'll be able to have a little bit of discussion with him. But Chris, I've already told everybody that the New York Post called you the anti-Greta Thunberg. So I wish I had an introduction that concise. But with that, let me toss it over to you, Chris. And I believe you have some slides you want to share with us to begin your presentation.
Yes, I do have some slides I put together kind of last minute. I've been very busy, but I think it's be a pretty good presentation. I like what I was able to accomplish for the last couple of days. And thanks for having me on. So it's a pleasure. So let me see if I can screen share real quick. It's been a minute since I've done this. There we go. Okay. All right. Are you able to see the presentation?
It's coming up now. There it is. You might want to put it in presentation mode. Hit that little flaggy thingy down in the bottom corner. There you go. Appreciate it, Chris.
All right. So, as John mentioned, I'm a meteorologist and I'm also a policy analyst for the Committee for Infrastructure Tomorrow at CFACT. So, this little presentation is just going to be basically what do we actually know about climate change and what does the actual science say versus what does the media say? What you have been misled to believe, probably. Although I imagine a lot of the audience here is probably well aware of the sensationalistic media headlines. I'm also going to talk a little bit about energy toward the end, just kind of my basic opinions on that, which are based on the facts that we have. So, without further ado, let's get right into it. So, a little bit about me. I have a BSc in meteorology from the Millersville University of Pennsylvania. I just graduated with that degree in back in May. And as I mentioned previously, I work for CFACT. So you often hear about there being this 97% consensus. 97% of climate scientists, and I'm going to use that term loosely, agree that warming is human caused and it's dangerous. And there's really not any actual evidence to support this claim. But it's a statistic that's widely cited and it's used against climate skeptics or critics of the climate crisis narrative in online discussions. But this figure was contrived in Cook et al. 2013. It's a peer-reviewed paper that's published in the academic journal Environmental Research Letters. And so how they got this statistic wasn't actually because it's a real artifact of what the literature says. Rather, it's based on manipulating the results. And the authors examined a total of about 11,944, so almost 12,000 abstracts, papers in different journals, matching the keywords when they searched up global climate change and global warming. And the topic of the papers themselves were not necessarily about climate dynamics or the actual cause of global warming. They might have been a hurricane paper discussing trends in hurricanes activity in, say, the North Atlantic Basin. And in the abstract, it might say, well, while there's no increase in hurricane activity to date, the models say that we'll have increased by, say, 4% in the wind intensity by 2100 due to anthropogenic global warming. And if it just says that last part there, that's counted as a paper that endorses anthropogenic global warming, that it's all human caused. But it turns out that of the nearly 12,000 papers, 66.4% of them, 7,930 of them expressed no position on the actual causes. And because they took no position, they were simply discarded from the analysis, as you can see here in the table 3 from the study. So that's not really how you would accurately do that. That's manipulating the data. So it turns out that out of the remaining papers that endorsed them, about 97% of them did. And that's how they got that statistic. So they ignored over half of the papers that they looked at. They didn't even look at the papers themselves. They simply looked at the abstracts of them. And climate activists often, so on Twitter or Facebook, if I post something that's contrarian to the orthodox belief system, I'm often accused of saying that people often tell me, the activists, they'll say, you don't know more than the scientists at NASA, NOAA, and all these universities. You're not smarter than them. Of course, I never claimed to be smarter than them. But that's just kind of their strawman argument that they like to come up with. And then they'll often cite a written statement from NASA or say some professional organization like the American Geophysical Union or American Meteorological Society, which I'm a member of, by the way, the latter one. They'll cite a written statement from them saying that climate change is real and it's this existential threat to the planet and it's caused by humans and something to that effect. And the problem with this statement is that while I do acknowledge climate change is real, and while I do acknowledge that, of course, the climate has always changed, and I also acknowledge that our your use of fossil fuels probably has some warming effect on the planet, which I'll get into, but that's not cause for alarm. The world's not going to end, which is the main point here, because there's a difference between, oh, okay, there's slight warming and Al Gore's Armageddon, we're all going to die. But professional organizations like AMS or the AGU, they will manufacture a consensus of scientists without first consulting the members, their professional members. A really good example of this was back in 2022. It was July 8th, 2022. The American Meteorological Society, again, I'm a member of this society, they issued a strongly worded special statement against the Supreme Court in their ruling in West Virginia versus EPA, which essentially limited the EPA's authority to regulate greenhouse gas emissions from power plants. And so they wrote, quote, the AMS is deeply concerned by the United States' inadequate response to climate change and the dangers it poses to the nation and all life. And then they go on to say that climate change is extraordinarily dangerous to humanity and all life. And the patterns of climate change occurring now match the characteristics we expect from our greenhouse gas emissions and not other potential drivers of change. And this statement was put out by their former executive director. Again, none of the members of AMS were consulted about this. This was simply a written statement that the organization took. And so while it might be their official position as an organization, that does not necessarily reflect the views on climate change from the wide range of views from its professional members. So we actually have an idea of what AMS members think. Back in 2016, again, this is a little outdated now, but I'd like to see an update to this paper. But this is the most recent information, the best information we have on what scientists think in terms of what their opinions are on climate. Now, I should have a disclaimer here that expert opinion, mine included, is not evidence of anything. Evidence, all science is numbers, and science and numbers revolve around evidence. So that empirical data, that's evidence. Physical observations are evidence. My opinion and model output is not evidence, although the IPCC, the United Nations, now considers that to be evidence. But sometimes it is useful to see what scientists think privately, because if they do a survey like this from which they did for AMS back in 2016, they can kind of privately tell you what they actually think about this versus what they're going to put in their paper to get it published. So this allows them to speak a little bit more freely without being threatened by the university to be fired or their government research position. So if you do it kind of anonymously, you can kind of get a better idea of what scientists actually think, even though that's not really necessarily evidence for or against one particular driver, against the drivers of climate change. So in January 2016, this professor at George Mason University polled over 7,500 AMS members at the time. I think it's over 11,000 members now. It's definitely over 10,000, but in 2016 it was about 7,682. And so they issued a survey and they asked a handful of questions, and the survey had a 53.3% participation rate. So a little bit over 4,000 respondents. That's not very good participation, but it's better than nothing. So based on the responses to this survey, we have some idea of what they think. So there were three key questions. The first was, regardless of cause, do you think climate change is occurring? The second question that was really important was, do you think that climate change has occurred in your area over the past 50 years, and what has been the cause of it? And the question 7B of the survey was, which of the following best describes the impacts of the local climate change in your area over the next 50 years? So this is really where it gets interesting. So 96% of AMS members, these are meteorologists, climate scientists, atmospheric physicists, all sorts of stuff. Regardless of climate change, regardless of cause, do you think climate change is occurring? 96% said yes, 1% said no, and 3% said don't know. So obviously, pretty much everybody agrees that climate change is occurring. And it always has for the entire 4.5 billion year existence of this planet. It has changed. Now, again, this is where it gets interesting. So, what do you think it has been caused by over the last 50 years? Only 29% said it was largely or entirely by humans, which they specify that as being an 80%, 81% or greater contribution to the observed warming trend since the 1970s. Now, 38% said it's mostly by humans. So that's between 51% and I think no, but sorry, between 61% and 80%. And then roughly equally natural or man-made, 14% said it was, about 40 to 60%. And then mostly by natural events, so up to 39% of the warming is the 7% said that, and largely entirely by natural events, 5%, don't know, said 6%, and climate has not changed, said 1%. So clearly there is a wide range of views here among scientists, and it's much more nuanced than this idea that, oh, it's all man-made, or oh no, it's all natural, which is what a lot of the tribalist, that's kind of the tribalist nature of how the politics has corrupted people's views that aren't necessarily scientists. So scientists clearly have a much more nuanced position on this, and there's a whole spectrum between it's entirely natural, entirely man-made, and somewhere in between there's a spectrum that most people will fall on. But a lot of the lay people that aren't scientists, aren't meteorologists like myself, they will split off into it'll splinter into two different camps, and that's not really good for science, but it makes for good politics and show. Now, for me personally, I would probably fall in the 7 to 14% of that survey. So really mostly natural events or roughly equally natural man-made. But either in any case of this tells us nothing about whether or not climate change is dangerous. So even if it's entirely man-made, that does not mean that the world is coming to an end or that we need to radically alter our use of alter our energy grid and get off fossil fuels, so coal, natural gas, oil. That is not, even if it's entirely man-made, again, does not mean we need to restructure our energy grid. So the last question was, obviously, what do you think describes the impacts of climate change in the next 50 years in your area? Mostly exclusively beneficial, 2% said that. Don't know, said 19%. Mostly exclusively harmful, about 50%. Equally mixed, 29%. So again, there's far from a consensus on this matter. There's clearly no 97% figure here. 97% of people aren't going to agree on anything virtually at all in this world. So what do scientists actually, if you were to go around and ask just about any other meteorologist or atmospheric scientist like me, what is it that they're going to largely agree on? There's three key things that people are going to agree on. One is that the temperature of the planet, the surface temperature averaged across the globe, has warmed up since 1850. And the 1850, of course, was the tail end of the Little Ice Age. So the planet was cooler back then, and it was the coldest point in the last 10,000 years. So that's something to keep in mind. We're at least part of this warming trend is a bounce back from that Little Ice Age period. And so 2010 to 2019 was probably the warmest decade in the last 175 years, but so what? Again, the planet's 4.5 billion years old. We also largely agree that atmospheric carbon dioxide concentration has risen since 1850 by about 51%. So we're halfway to doubling it from the 280 part per million, roughly stable level it was for several thousand years up until the Industrial Revolution. And this increase is primarily due to fossil fuel combustion. Some skeptics will argue differently, but I don't really think that those arguments are valid because of the isotope footprints of the different carbon atoms and stuff and how that works out. But again, the other thing that people will largely agree on is that CO2 and some other greenhouse gases have a warming effect in the lower atmosphere. So some of the warming that we've seen over the last 150 years, 175 years is probably due to our emissions, to some extent. But again, I'm going to have this in bold in orange here. That's not necessarily cause for alarm. And in fact, a lot of the benefits of a warmer planet or a CO2 enriched atmosphere are largely ignored by the scientific community. So global warming theory in a nutshell. So the first thing we need to establish here is that the temperature of anything, whether it's your body, a pot of water on the stove, a cup of coffee, your car engine, whatever, that's a function of energy balance or energy imbalance. It's not a function of energy gain alone. So if more energy is gained into a thermodynamic system than is lost, the temperature rises. And if more energy is lost than gained, temperature falls. Pretty basic thermodynamic concepts. Therefore, the average surface temperature of the Earth is a balance between heat energy gained through the absorbed solar radiation from the sun. This is in short wave, so very high frequency, very short wavelength energy, and the energy that's lost to space through the Earth's emission of infrared radiation, which is very long wave and very low frequency radiation. So that's how Earth cools. So understand that in atmospheric physics, and when we're talking about radiation fluxes, the heat flux is measured as the power standardized per square meter of surface area. So this is watt per square meter. A watt is essentially joules per second. Joules is a measure of heat energy. So that's how we measure heat flux, is watts per square meter when we talk about radiation flows in and out of the climate system. So the average radiation flux into the Earth's atmosphere is estimated from satellites to be about 239 plus or minus 3.3 watt per square meter of absorbed solar radiation averaged over the course of a calendar year. This figure has been known for decades, since at least the 1960s. And you'll see some estimates that go from 238 to about 241. So there's a 6.6 watt per square meter margin of error on this estimate. That's a pretty large margin of error, and that's going to become important in the next slide. Now, this means, let's just go to the 239 watt per square meter figure. This means that to maintain a constant surface temperature, the Earth must emit that same amount of radiation back to space. Again, temperature stays constant if energy in equals energy out. If energy in is greater than energy going out, temperature goes up. If energy going out is greater than the rate of energy coming in, the temperature goes down. So that's an important, just important basic concepts here that I think anybody can understand. This diagram here from Stephens et al. 2012 gets a little complicated, especially on the right side of the diagram. I'm not going to go into explaining how all this balances out, because it would take me probably 30 minutes to do that, and I don't feel like doing that, and we don't have the time for that. But just this is an important, this energy imbalance is 6.6 watt per square meter, 3.3 times 2 is 6.6. That in uncertainty in the natural energy fluxes, again, this is natural. This is going to be really important coming up here in this slide here. So climate models are fudged. And actually, I think there's something wrong here with this slide. Let me see something real quick. Okay, maybe the slide got deleted. Anyway, my point here with this slide that I wanted to make here, let me go back real quick. My point with this slide about this uncertainty is that the energy imbalance from CO2, the current energy imbalance that's been caused by our emissions, is estimated to be about 1.1 plus or minus 0.48 watts per square meter. That's just 1.1 figure. One is 6 times lower. The uncertainty in the natural energy fluxes is nearly 6 times larger than the energy imbalance caused by CO2. So what I want to make clear here is that the larger margin of error on the natural energy flows versus the imbalance supposedly caused by CO2, because that's much larger, nearly 6 times larger, that means that most of the warming we have seen could be natural, and we would never know. Or it could be mostly man-made, and we wouldn't know. We just don't know. And it's okay to say that in science. And the point is that it's far from settled. Now, this is where things get really interesting. So climate models are fudged. So this chart here is really popular with the climate alarmist crowd. And this chart shows, this is from the IPCC Summary for Policymakers. And it shows, the black curve here shows the observed temperature trend. And again, there's a lot of uncertainty about how much it's actually warmed and how accurate these surface temperature measurements are going back, because there is a huge error on that, especially prior to World War II. But let's just assume it's accurate for sake of argument. So the black line shows the observed temperature change between 1850 and 2020. And The brown curve shows the simulated change in models. These are climate models. They're called global climate models, or GCMs. This shows the simulated human and natural component. And then the bottom shows the simulated natural forcings only, which, and of course, they're very simplistic. The climate is a chaotic system. It can change with or without forcing because it's chaotic. That's designed by nature. But the IPCC only looks at solar sunspots, basically, sunspot activity. So that's the solar forcing and volcanic activity. They don't look at really, they don't really look a whole lot at internal variability, at least in terms of how that affects and modulates heat storage and transport across the globe on multi-decadal timescales. So their models are tuned to the fact that, oh, well, solar can't explain it, volcanic can't explain it. So we'll just tweak it with some greenhouse gas forcing, and that's how we're going to get this curve. And what's funny about this is the IPCC avows that this is based on a synthesis of information from multiple lines of evidence. That's literally a quote from their Summer for Policymakers, and that's just really just junk science. And the IPCC also states that climate models, which again is the curve here with the brown and the green, but the brown is the combination between the man-made and natural forcing. The IPCC states that the models have done remarkably well to explain why the Earth's temperature has risen since 1850. And this plot also implies that virtually all warming over that period is due to mankind's greenhouse gas emissions. So this gets problematic for a few reasons. So if you go to figure 3.8 from chapter 3 of the IPCC AR6 report, you will find this diagram here, and I annotated it very similar to how Dr. John Christie, who's the Alabama State climatologist and professor of atmospheric science at University of Alabama in Huntsville, he did a chart. He showed this chart in a presentation, and he annotated it very similarly. And so I did my own adaptation of that chart from the IPCC. Now, so let's go to this chart. Let's break this chart down a little bit. So the green box here, the green boxes show the spread in the model temperature change since 1850 ascribed to both natural forcing and internal variability. And climate models show essentially zero contribution from natural forcing and internal variability to the global temperature change since 1850. And this is because when you simulate climate models backwards, they regress towards the mean, and they cannot get any sort of up and down variation in temperature that we see in the ice core records or sediment proxies. The climate models just produce a flat line essentially. And so that's considered, well, the scientists just throw their hands up in the air and they say, well, okay, natural variability is zero. So that's what they put, that's why they put this box here at the 0 degree, around the 0 degree Celsius contribution to temperature change since 1850. And of course, they ignore other first order forcings like land use change and urbanization, which have huge spatial patterns and distribution that really do affect temperature trends locally and by extension globally. And then they go on to, so now they're left with the change between the greenhouse gases and aerosols. Now, aerosols are these fine, tiny particulates that are suspended high in the atmosphere, such as like pollen, dust, salt, spores, all sorts of stuff. And they can, they're like things like black carbon that can actually absorb incoming sunlight, and they can really warm the atmosphere. And if they're things like sulfur dioxide, which then become sulfate aerosols, they actually reflect out solar radiation. This is what the volcanic activity spews up into the stratosphere. Now, this is really funny. So the aerosols, the IPCC says, based on the models that they included from the literature, aerosols may have had a net cooling effect by about as much as 0.9 degrees Celsius since 1850, or as much as 0.1 degrees Celsius of warming. So they could have either warmed or cooled the planet. And there is a 100% margin of error on that estimate. A 100%. How is that settled science? Now, in order to find, they have a best estimate. So they counter that with a really strong greenhouse gas forcing. So this is let's make this a little less complicated for you. And I was trying to figure out before the presentation how to best explain this. So do you see, let me get a little pointer here. If you see, oh, I can do a pen. Look at that. Can I draw? Okay, there's this model right here. It's shaped like a hospital cross thing. So we can see that the aerosols have a really strong really strong cooling effect on this Hadley Center model. They cool the planet by about zero point 0.9 degree or by about zero point 0.9 degrees Celsius since 1850. And so they say, oh, natural variability is 0, so that goes away. Okay, let's cool the planet. Let's tweak the model. Let's cool the planet since 1850 with aerosols by zero point 0.9. Let's say that's how much it cooled. Okay, well the planet hasn't gotten cooler; it's gotten warmer. So they just counter that with a really strong greenhouse gas forcing up here, with again the gray. So that's not science. They're just fudging. They're just fudging parameters until they get their desired result. So again, to make this short and sweet, to go over this again, just so we're clear, they say that in the Hadley Center model, which is again the one I circled, it's right here. Natural variability is 0. Okay, so let's put in some aerosols into this model to see if we can get the model to simulate global temperature change, because they're trying to recreate the temperature the trend that has been observed. And they don't really know what's going on with internal variability. So that's 0. Okay, let's cool the planet with aerosols. We know it's cooled the planet by, let's say, this much. And then that's too cold, so they just kind of Goldilocks it and they put a really strong greenhouse gas forcing. So that's basically the gist of this. And so they set a target range here, between points, zero point 0.8 and 1.2 degrees Celsius, something like that. And that's how they get the model to do it just by fudging parameters, essentially. They are able to get this plot here on the previous slide. And they claim that's evidence. That's not evidence. That's just tuning models and fudging data to get a desired result. And yet that's considered to be the evidence that virtually all global warming since 1850 has been man-made. And for years, scientists were very hush-hush, very mum about their model tuning practices. And even in IPCC AR6, they don't talk about it that much, but they did hint about it in AR5 back in 2013. And then in 2016, this Science article came out where they talked about how scientists deliberately kept quiet about their model tuning practices because they felt that climate contrarians and skeptics would use the practice of artificial tuning against them. And so this quote right here from this article in 2016 just goes to show that the scientific community did not want the public to know about this. And this is the kind of supposed science that's going into these models that are being used to justify policy making. So in order to, so what are they, so again, I want to go back here. So they tune the models. They tune climate models. These scientists tune models to agree. They force the data to agree with the surface temperature record, say the Hadcrete data, which is what this is from. They force the models to agree with the data to then conclude that the models agree with the data. That's circular reasoning. That's not actual science. So in order to do a fair comparison between what the models show, in this case, this is the CMIP6 plume, which is the latest, to see what how the models are actually doing against temperature observations, we need to look at a data set that's not that the models are not tuned to. And one of these data sets is the global lower troposphere. So the troposphere is the lowest layer of atmosphere, extends up to 4 to 13 kilometers in altitude, depends on where you are. It's higher in the tropics, lower in the Arctic regions, closer to the 4-kilometer level there in height. The lower troposphere is important because it's a measure of the bulk heat content of the atmosphere. Not the surface temperature just is the surface temperature, but to really get a good thermodynamic understanding of what the heat content is in our system, we can look at the ocean heat content data or the bulk atmospheric temperature, which is what this is, because this is about 80% of the atmospheric mass by volume. So when we're looking at this is a true measure of how much heat content is in the atmosphere. And because the models are not tuned to this lower tropospheric temperature data, it's a good fair comparison. It's a more apples to apples comparison, rather than doing apples to oranges where you're doing circular reasoning. So this here is the data in the blue with the circle dots. That's the observed temperature trend since 1979. Obviously, a limitation of satellite data is that it only goes back to the late 1970s. It'd be nice to have a lot more data than that. But since the 1970s and 1980s, it has gotten warmer. There's no doubt about that. But of course, I should emphasize here that if we didn't have these measurements, you wouldn't be really wiser to the fact it's gotten a little bit warmer. because we're so used to experiencing huge temperature swings on a day-to-day, on a year-to-year basis, season to season, that the idea that we can't adapt to a slight change in the yearly average is just asinine. It really is. There's no scientific justification for that. Um, Especially when you're talking about creatures that are on land. In the ocean, you might have a better argument for that because those temperatures are very slow to change, and a very slight change like in an aquarium, that might be different. But for land-based animals, we're easily adaptable, as well as species. So these other curves here show the different IPCC scenarios. And this shows the change in the temperature projected due to from the models of the different scenarios. This is the CMIP-6 plume. Virtually all of them run too hot. And it took the Hunga Tonga eruption recently and the El Nino to get us anywhere in that ballpark. And I imagine the temperatures this year have been cooling off quite steadily, so they'll probably fall somewhere back down here by the time we get into the end of this year or next. So the models produce nearly a factor of 2 of warming. They produce way too much warming than observations show. And this is especially true over the tropical upper troposphere, around the 200 to 300 millibar level. That's in the mid troposphere, the tropics. All the models produce, they moistened it too much with really strong convection and latent heat release because of that feedback, and it produces way too much warming in the tropical upper troposphere than has been observed. It's called the tropical tropospheric hotspot, and virtually all climate models show that that should be occurring. But in reality, that hotspot in the tropical upper troposphere, and I should have put a cross-sectional diagram in here for that, but I didn't have time. It does not show that warming. So clearly, models are not fit for policy making or really science in general. We got a lot of work to do. So the other thing I want to close up with here with, just briefly and touch on, this is something I'm not as much of an expert in per se. This is something that I've only recently in the last couple of years have really decided to dive into this angle of it, is the whole energy policy side of it. But one thing is certain, we are far off from an energy transition. In 1995, fossil fuels, I think, made up about 76.8% of our energy consumption, and that was 30 years ago. And today it's 76.5%. So we've only dropped by 0.3 percentage points over the last 30 years. And we keep hearing about this energy transition and the fact that solar is taking off. And it's really just not, because they add to overall energy consumption. They don't replace fossil fuels. So despite the fact that solar has gone up, which is fine, it has not brought the use of fossil fuels down, because a lot of countries, especially developing countries, need affordable, sustainable electricity, and that's going to come, like it or not, in the form, to the alarmists, it comes in the form of fossil fuels, which is primarily coal, and natural gas for electricity needs, and oil for transportation. The other thing that's important to note here is that the higher a country its CO2 emissions are, generally the higher the GDP. And this is obviously on a per capita basis to kind of standardize it for a more accurate comparison. But countries, countries in North America, like the United States, obviously here, Canada, have really high GDP, have high CO2 emissions per capita, and China is also up there. Countries that have lower CO2 emissions, a more green energy grid, have lower GDP. That's just a fact. And that's because renewable energy sources, primarily solar, photovoltaic, and wind, are very intermittent energy sources. They're not very reliable for grid scale use. Now, solar is going to definitely improve over the next 10 to 15 years, and I think it's great for people to put it on their houses if they want, especially if they're living off grid. It's good for powering your electricity appliances, stuff like that. But the one limitation with solar is that on your house is that you cannot usually run a lot of the heavy appliances at once. Like, you might not be able to do your washing and drying and then do cooking at the same time. You might have to do one at a time. And some solar setups aren't even able to power those heavy appliances, period. They can just basically do the electricity. But wind, the problem with that, one problem I do have with solar is that we should not be clearing tens of thousands of acres of land to put up solar farms. or wind farms. That's counterproductive. That's more environmentally destructive, I would say, than continuing to use coal, oil, or natural gas. It's asinine to destroy the natural habitat. I'm a land conservationist. I like our national parks. I like the wilderness, and I don't want to see it destroyed, to put up solar and wind farms. Because nice thing about coal and natural gas, as well as nuclear power, which I'm a big fan of, um, is that those energy sources are very energy dense. You don't need a lot of land to use them. And that's just a fact. And solar, the physics of it may mandate that they're not going to be able, and wind especially, or mandate that they're not going to be able to replace fossil fuels, at least anytime soon. The other thing that's important here to note is that, and I put this chart together, and I know Lombard did too, did a similar chart. There's essentially no country with a high share of solar or wind power on its grid with low residential electricity prices. Because of the climate hysteria and obviously those climate models, which are showing the projections for the future, have driven a lot of the energy policy in Europe. You see how high look at Denmark. Nearly 70% of their electric grid is from solar and wind combined, and they have one of the highest electricity prices in the world. They're running at like 0.35 cents what is this? Oh, it's a US. It's so yeah, cents a kilowatt hour. So that's crazy. And Germany and Ireland, Belgium, Italy, United Kingdom, these countries in Europe have really bought, hook, line, and sinker into this green narrative that climate change is an existential crisis. And based on those climate model projections, which are clearly based on faulty data, and they have basically wrecked their economies, and they have made the cost of living unaffordable for many people there in that part of the world. Countries that have lower grids have depreciated assets that have worked well over time. The United States, China, India, Japan, they all have much lower electricity prices than those other countries. Now, obviously, this chart isn't necessarily, you can't attribute all this to green energy. There is a lot of course, in Europe, very high taxes. They also have to import a lot of natural gas. So those obviously come with additional fees. But there is a correlation here. And also the taxes on energy that they have in Europe is also because of the green energies push. So either way you look at it, whether it's renewable energy or it's the taxes, it's all part of this same ideology that climate change is an existential crisis, and it's based on these model projections for the future that is really built on really faulty evidence. And so that's not sustainable moving forward. If there was any serious, if the activists were actually serious about really wanting to change, and there are some out there who do, and they advocate for nuclear. But most of them don't advocate for nuclear power because nuclear power is the only power that can serve as a societal baseload because it's energy dense. It's the most energy dense source. It's the most efficient energy source, and it's the least land intensive energy source. And it's also the cleanest in terms of, well, I don't like saying clean energy in terms of a carbon footprint because carbon dioxide is not in my opinion, it's not a pollutant. The EPA only classifies it as a pollutant because it's a greenhouse gas, and they're getting rid of the EPA endangerment finding, obviously, which I think is a good thing because that neglects the importance of CO2 in our biosphere. Better plant growth, a little bit warmer is better for humanity. So there's the benefits, in my opinion, in my educated opinion, outweigh the costs of higher CO2. And but if we were to go along with this narrative that CO2 is dangerous, then nuclear is the best option that keeps our economy running, and it's the best option for the activists to get their carbon-free energy. The problem is they don't ever endorse nuclear because it represents an economically prosperous future, whereas for solar and wind means the government can mandate it and regulate it and ration it to people. But regardless, even if we had nuclear power, we're still going to need coal and we're still going to need oil because of oil for transportation. But we're still going to, for our electric needs, we're still going to need coal and natural gas. And the main reason for that is because one problem with nuclear is that it cannot be generated on demand like coal or natural gas can. So when you have when you have a sudden demand spikes in energy, you're going to still need a coal, and you're still going to need a natural gas plant to provide that backup when nuclear can't get up and running that fast to meet demand. So that's my understanding of it, and I really think that scientists need to be better communicators to the public about this, because when they get on board the activist gravy train, they really do the public a disservice. And we have a whole young population as well as an elderly population. There seems to be, I don't like to generalize at all, but there seems to be a really big, I see and the people that seem to buy the most into climate hysteria in this green energy initiative are young people like myself who believe everything they see on social media, and people that are probably 65, 70 plus. Obviously, not everybody, I'm not trying to be ageist, but a lot of people that are elderly tend to watch CNN or MSNBC all day. They are used to watching the cable news, and they've done that their entire lives because that's what they grew up with. And a lot of people that are my grandmothers, for example, they're both 80 years old. They don't buy into it, but a lot of their friends their age do buy into it, and they have to explain to them the stuff that, you should check out Chris's stuff. So the people that tend to be more skeptical tend to be people that are probably in their 30s to early 60s. They tend to be much more critical of this. The people that are in Gen X or the early millennials, they tend to be more critical of this. And I think it's important that scientists emphasize this to older and younger generations, that it's not as bad as we say it is, because seeing this level of mass psychosis with people that are scared about climate, and they want, they want this radical change, it's not feasible. That's not going to be good for future generations moving forward. And so that's it for my presentation. I'm happy to take questions.
Chris, that was an outstanding presentation. Thank you so much for taking the time to put all that together for us. Reminding everybody the chat box is open. If you've got questions, you can type them in there. I've got an eye on it, or you can unmute yourself or do the raise your handy thingy or whatever you want to do to join the conversation. We did have one comment while you were talking, Chris, when you talked about taking lots of arable land out of service to put solar panels over it. We had Sophia said amen to that. We need to be putting solar on parking lots.
Absolutely agree. Solar over parking lots, solar on the roofs of your homes. If you want to do that, that's fine, but we should not be clearing out land and destroying ecosystems and wildlife to put it up.
And
also the government should stay out of it. It really should be up to the free market consumer to decide which energy technology is superior.
Yeah, and by the way, the Interior Department just this week or last issued a directive that they're no longer going to be allowing any incentives for renewable energy projects that take arable land out of commission. So again, one of the
I did not see that.
Yeah, it's just brand new, but it's one of the many policy correctives that are in process right now. I wanted to go back to your original slide a little bit, Chris, where you talk about the 97% consensus, and let me check two things on you. One, is there pressure on scientists who need funding to do proposals, to do papers that they know are going to get funded? And number two, there was some publicity recently about the number of papers that are getting published that come from these paper mills that might not be science at all. I mean, could that be part of the data set of all these papers that people claim are supporting the 97% consensus?
I have heard to the second point, I have heard a little bit about that, but I don't know enough to offer an educated comment on that. So I'll have to look more into that second part. But it definitely does not apply to the original study that came to that conclusion, because that was between 1991 and I think 2012 or somewhere around then that they looked. Yeah, it was between 1991 and 2012. So any of this other stuff that's coming up could be definitely problematic if that's what's indeed happening. But the first point I could definitely comment on with confidence. And that's something I always like to tell people, is that if I don't know something, I'm not going to offer a comment on it until I get a better educated opinion on it, because I don't want to babble on about something that I don't know about. And I wish more people did that, because a lot of people, especially on social media, pretend to be experts in everything. They tend to be, they politicians, especially in debates, they're like, oh, I know to do with healthcare or whatever. But anyways, I'm kind of going off on a tangent. So A lot of people will claim, and I love this, they'll say, oh, you work for CFACT, you're a fossil fuel funded shill. Well, CFACT hasn't taken a single cent from the oil industry in 17 years. And when they last did that, I was 5 years old. I'm 22 now. So I've not taken any fossil fuel money. That's not, I don't, we don't get fossil fuel money at CFACT. So that's always a laughable argument. But they alarmists use this argument because, fossil fuel if ExxonMobil is paying me big bucks to sow down climate change, that would be a conflict of interest. And yeah, I would agree with that. But we never talk about the conflicts of interest with these organizations, these environmental advocacy groups that fund scientists to do studies for NGOs that really cast alarm on climate change. They'll over exaggerate the impacts or extreme weather trends or something, or they'll cherry pick starting dates to get a desired upward trend. And there's also conflicts of interest within the government funded research, the taxpayer, I should say, funded research, because when it was decided decades ago that we were going to put the federal government, really specifically politicians, in charge of allocating and apportioning funds for research and development into science, it put politicians and policy goals basically in charge of where that money goes and what it would be used for specifically. And it would have a biased outcome towards results. And so scientists, especially academics in universities and also government research scientists in the Series 1301, the physical scientist positions at these government agencies like NOAA, NASA, all those places, these scientists, we now have a army of foot soldiers whose careers and their success to get tenure, to get tenure at a university or to continue to get more research funded so they don't have to pay out of pocket. Their career success and getting published is important for scientists that are in the research field, because if you get published in a respected journal like Nature or Science Magazine, although I would say that especially Nature has degraded its credibility significantly with their presidential endorsements. Scientific publications should not be endorsing presidential candidates, period. Whether it's Trump or Biden, or I guess Harris after Biden dropped out, they shouldn't be doing that. But to get published in these respected publications, it takes a lot of effort. And once you do it a few times, you're more likely to get published in that journal again. And if your work is perceived as important by other academics, other researchers, they'll cite it. So you'll get a higher H index, and you'll get more references, and you'll get more papers published, and that will set you up for getting awards and accolades at these prestigious organizations like AGU, AMS, Royal Society, whatnot. And because this research is largely funded for by the federal government through taxpayer funds, so we now have again a foot soldier army, an army of scientists whose careers depend on that funding, and that has resulted in a research bias in the outcomes that tend to support a more alarmist narrative, because the government only funds people to study problems. And if Congress decides that, oh, climate change is not a problem, they're not going to want to put research and development, funds towards that to study it to advance their policy goals. They're going to look for other mechanisms, other issues to put money towards to get scientists to come up with research to put towards their agenda.
Understood. Yeah, it's interesting situation. It's an ecosystem of its own, right? Where the
Yep.
where the feedbacks come in. We're coming up on the top of the hour, and we're very grateful to Chris for taking the time both to prepare and spend time with us today. You mentioned before, check out Chris's stuff. Where can we check out Chris's stuff for those of us who'd like to I don't know, I'm too old for the social media stuff here. Slip into your DMs or whatever. Where should we find you?
You can find me on Twitter or X at Chris Martz WX. You can find me on Facebook there as well. I run a blog, chrismartzweather.com, and I don't post there often, but I do have really good stuff there for you to read if you're interested in extreme weather events, which is something I wanted to include in this presentation, but I knew I wouldn't have time for. But if I get the opportunity to come back and give another presentation, I'll probably make that one focused on extreme weather, which is my favorite thing to talk about as a meteorologist. And you can also find, of course, my team and I on the web at cfact.org. And there's one last thing here in the comments I just see. And so this person, MFM, I don't know, I guess those are initials. This person asked, is it fair to summarize your views that CO2 and other greenhouse gases are having an impact on global temperatures, but that we do not know the amount, and that other things, natural trends, solar activity, volcanic activity, etc., are also having an impact? Yes, yeah. I mean, the basic physics behind global warming theory are pretty well understood and accepted by most skeptics and alarmists alike. CO2 is a greenhouse gas. All else being equal, if nothing else changes, more CO2 equals slightly warmer, but it gets only about a 1 degree Celsius change per doubling of CO2. So it gets because it's logarithmic effect, because it takes longer to increase the concentration. It's actually kind of a logarithmic. So the more CO2 kind of get, the warming effect gets weaker with time. But we really do not know the natural energy flow precision with the Ceres satellites to measure the natural energy flows, because the energy imbalance is much greater. That's much greater than the energy imbalance supposedly caused by CO2. So it's a very chaotic dynamic system. There's a lot of factors that go into shaping the climate, and we just don't have all the answers.
Well, that appreciate that, Chris, and maybe we can get you back at some point to do the presentation on extreme weather events. I know there's one you're keeping your eye on right now,
Yep.
off the East Coast. So we're at the top of the hour. We'll let you go back to looking at hurricanes, and remind everybody, fall meeting, October 13 to 15. Join us in Scottsdale for that. We will be back here next month. Look at the we're just pinning down our On Track Live speaker for next month. Hope to have that announcement out in tomorrow's newsletter, so keep an eye out. We'll be here same bat time, same bat channel in September for On Track Live. We're going to take October off because you're all going to come see us in Scottsdale. But Chris, thank you again for being here with us today. Really appreciate it. Lots of clappy, handy things going on down here. Appreciate it. And yeah, maybe we can have you, if you're up for it, maybe in the future, we can have you come back, talk about extreme weather too. I know it's something I'd love to hear your views on.
Absolutely. I got a wealth of information on that to present, that a lot of people, some stuff that I've been working on independently, that's not other people's research, stuff that's my own stuff. That's interesting. So thanks for having me on.
It's impressive. I know some other 22-year-olds who don't even know what research is. So thank you for your intellect and your engagement, and I appreciate your time here with us today.
Thank you.
Take care, everybody.